So the first part of looking at the integrated design process, looking at passive solar, is our first step towards energy efficient design. Looking at the site that the building is going to be built on, looking for good solar access, where we have good southern exposure in the summertime. We don't have a big hill or trees or something that's going to block that southern exposure, because we have that free energy from the sun. We might as well take advantage of it as much as possible. The orientation of the building, this can be, we run into this a lot in Montana because we have amazing views in different directions. And more oftentimes than not, we get a set of plans into our office and someone says, you know, help me make this energy efficient, and they have a huge wall of glass facing north. And the amount of energy lost through that and the comfort issues associated with that is huge. So it's a challenging detail, but for energy efficient design, the orientation definitely needs to be carefully chosen with proper glazing on the different orientations, looking for solar gain windows on the south side and solar shield windows on the east and west, where we don't want to allow as much of the sun's energy in.
And one of the big things with passive solar design is making it's not only for heating the building, but it's for keeping it cool in the summertime. And so, you know, a lot of glass facing west, or not having the right eave overhang on the roof. There's a bunch of details that can cause the building to overheat, particularly in the shoulder seasons or the summertime.
Yeah, so the eave overhangs is a big part of it, and that, you know, that's going to definitely drive the roof design or the shape of the building, making sure that we have proper overhangs on the right sides. The layout of the rooms to allow for the sun in the areas where we spend the most time, like the living and kitchen and dining areas. That's where we want to get the most sun on the southern exposure. The rooms that are not used as much, those we'll want on the north sides. Like your bedrooms, laundries, baths, that all can be on the north side of the building where you're not spending as much time.
We actually, you know, we actually offer training in passive solar design if that's something that you're interested in. You know, there's a full day's worth or more of stuff to go through on passive solar design, but we're just touching on the very highlights of it here.
Yeah, Andy's got a lot of experience in passive solar design. He put together a brief presentation on passive solar design. It's on our website under the resources section. It's kind of an introduction to it, and if anyone's interested in going further with it, we'd be happy to help with that. The insulation and air sealing, ventilation, all those same issues that we're going to be talking a lot about today really affect how a passive solar designed house performs. So carefully paying attention to how much insulation, air sealing details, and what the ventilation strategy is for the building.
Thermal mass, the next point, is another key thing with passive solar design. It basically stores heat. A lot of people think that putting brick on the outside of a building is adding thermal mass. No. The thermal mass has to be on the inside of the insulation, the thermal boundary. Otherwise, it does absolutely no good as far as helping to regulate temperatures inside the building.
Landscaping is the final point on there, looking at, you know, strategically planting trees and other shading devices to help to prevent sun getting in on the west and east sides of the building, and to allow the sun to get in on the south side.